Okay, thanks a lot. So here it is right here. So I got to do the repair. So let's see how we're going to do this thing here. So the material itself, and once I clean all the paint off of it, it's all been cleaned. So it's got paint off, all the red, all the crud on it. By the look of it, it looks to be like a casting. I don't think it's forged. Now that's going to change how I weld it, okay? If this were a forged tool steel, I would preheat it and do something differently. But it's a casting, so, because you can see right here, here's the casting line right there. So it isn't like a high quality, it's not expensive, it's not that good. If this were like, you know,
you can make it yourself essentially?
Nah, it's not an expensive part. Now if this were like a Swedish, or Japanese or Swedish axe, like a forged, really expensive one, I would do a different process here. But since it's kind of like a homeowner special, we don't need to preheat because I don't think it's gonna do anything. But what I did do is I ground down into it to completely root out the weld here, okay? So when you look at this, this is the weld symbol for that U-groove, the U-groove symbol. That's what this is, okay? So you have a butt weld going together, butt weld, but I can't get in there. I gotta get penetration in there. The only way is I gotta get the weld where it needs to go by removing metal in the way. So the U-groove is the grinder blade grinding into the material. That's why it's shaped that way, okay? The U-groove says, use a grinder. Get down in there. Now I couldn't V-groove it because I can't take the parts apart. V-groove, I can take my parts apart, use a grinder or a saw. I can't do that here. They're in position. The only option is use a grinder. So I ground down all the way to the root of the crack. So that's what I need to get down to. I'm gonna re-weld this with new metal, okay? So it's ready to go. Now, one of the things I wanna do here is before I go, give it a wipe down, of course, with acetone. So before doing any weld or repair, you gotta follow these cleaning procedures. So those of you when we get to the TIG welding things.
No, I know, it says low power.
Okay, so when we get to TIG welding, you gotta do this with everything you're doing. Those of you who wanna do the star, it's a lot of cleaning. So if you wanna TIG weld that star thing, it's a lot of work. So if you wanna do it recommended, get started as soon as possible. I'm not kidding, it's a lot of work. You gotta clean, all 60 parts have to be prepared like this. So it's very laborious. A lot of TIG welding is not just the welding, but the labor. The labor involved is, that's one of the things that makes it difficult. There are a lot of people that just want to cut corners. They're lazy. And then they're like, why am I TIG weld so bad? Well, because you don't understand. It's like, you can't be lazy about it. You gotta actually be precise, It's like cooking. You can't just pick stuff off the floor and throw it into a pan.
Yeah, you definitely can't.
So I want to adjust the angle here, okay? So we're gonna fit the work to the worker, okay? So what I'm gonna do here is I'm gonna tilt this. Use my blocks. I'm gonna tilt it so that my weld is at the optimal angle, which is a nice, easy 1G weld, groove weld, straight down by moving my work. So be smart, angle the work to suit where you are. If I'm like this, I don't have to be down here like, I can't reach in there,
Yeah, that's right.
I want to fit the work to the worker. So I'm fitting the work to my comfort zone. Right here, nice up and down. I want to wipe off my wire, make sure it's clean. And the wire I'm using is a plain old mild steel ER70. Now, even though this is tool steel, so why don't you use a tool steel wire? Here's the thing. High carbon, right? High carbon, what happens to high carbon when it gets hot? It gets brittle. Yes, it gets brittle. It can crack. So when you're welding carbon steel, use a low carbon steel. It acts like a shock absorber. It welds two parts apart. It allows it actually to flex a little bit. It has a little bit of a give. Think of it almost like a rubber bushing between two pieces of metal. It allows these harder parts of metal a little bit of give so that it doesn't re-crack. If you weld it with a hard tool steel wire, it'll end up re-cracking on you. Now they do make tool steel wires, but they're usually done for hard facing, like welding an edge onto a chisel or something, repairing a blade edge. But in this case, we're using a mild steel wire. Now, I could use something like, I could use silicon bronze if I wanted to. I could use that, but I want to use my maximum strength here. Silicon bronze is a brazing wire. Brazing is like glue. It'll be in there, but it's not going to be spreading into the base metal and welding to it. It's just going to sit on the surface. It might hold. It might, but it might not. But I want to make sure it does hold, okay? Because remember, this is an axe. He splits wood with this thing. So I want to make sure it doesn't come flying off the handle, okay? So in that case, I want to use my best practices. So I'm going to use this wire right here. I'm going to run a root into here, and then I'm going to weld it out. So being as it's fairly deep, I'm probably going to do this in, I want to do this probably in 2 to 3 passes. I'm not going to do it in one pass, okay? Now you say, well, I could do that in one pass. Yeah, you could, but you'd have to pump in so much heat. This thing is going to be like glowing yellow. And glowing yellow, you're going to cook this metal and you're going to kill it. So I'm going to do, I'd rather do smaller passes at lower temperature and then build up as needed. Better practice. Don't bite off more than you can do in one shot, okay? Be conservative, just be easy, don't kill it. Being as I have cracks here, I'm going to do something where I'm going to put a weld right here, I'm going to weld here, and I'm going to seal these cracks first. So I'm going to do that because if I start welding here and I go that way, as the metal heats up, it's going to expand and the crack is going to do something called propagate. And it's going to go shoot right down the material. Same thing common with wood. If you have a crack in a piece of wood, and you stress it, it'll just go right down the thing. Metal does the same thing. So if you have a crack in metal, you have to arrest it somehow. Like put a weld at the farthest end where the crack is, and that'll keep it from spreading. So when you're welding a cracked material, you have to address the crack first, then you weld out the crack. Otherwise, you'll be chasing it through the material. Before you know it, you could split your whole thing apart very easily. Very common with cast iron. Steel, not so much, but cast iron, very common. All right, so here we go. Could you turn up my amperage 200, please? Other way, other way. So being as it's a very thick piece of metal, I want to boost my amperage and start off with as much heat as I can to get my weld pool going.
Is that 200?
Great, thank you.
Okay.
So I want to adjust my angle so that my wrist is at my optimal angle. See, I want to weld this way. So that's not quite working. So I'm going to move this at an angle and make sure that I'm at a nice comfortable position where I can hit what I'm welding comfortably. And I can actually get in there. Move this out a little bit, right there. Take all the time you need for setup, okay? Nobody's going to rush you in setting up. In fact, we want you to take your time setting up, because it's critical. If you're not set up correctly, everything, just like layout for everything else, everything depends on that. If you're not laid out correctly, everything else is going to unravel very quickly. So take your time. I feel comfortable. This feels pretty good. I'm going to put this over my elbow. So I want to nail this end first shut, then I'm going to do over here. All right, here we go. I'm going to extend my tungsten out a little further so I can get down to my crack a little bit. I think that's okay. Let's see what happens. Let's see. All right, cover. Now you might notice, does anybody see little bubbles and hissing in there? Yeah. Okay, that's very distinctive for cast materials. That's a dead giveaway right there. So it's a casting. Castings have trapped gases inside of them. Even though it's a solid metal, a casting is like a sponge. There's a lot of empty space in there. The empty space is filled with gases. And when you weld on it, those gases bubble out, almost like carbonation. And you'll see like hissing and popping, sometimes little sparks. Real pain in the butt. You can see right here, my first tack actually cracked. You see that? Because the casting is shriveling away from the weld. So I'm gonna get back in there and add some more metal and hopefully layer it shut, and we'll see what happens. It's not always gonna be successful.
What are the typical recommendations? Because it's still appearing right, they made changes. I just want to make sure I'm not buying myself.
No, you won't blind. Turn your, what's your shade set to?
I put it all the way up to 13. And then I put like the sensitivity up to halfway.
All right. I mean, right now my shade is set to 9, everybody. So, yeah.
Put it on.
Y'all good?
You might keep it at 8 or whatever.
Y'all good there?
One side is like.
All right. You ready? All right. Let's get those helmets back on. Let's continue. Y'all good? Cover. Here we go, folks. Cover, cover. All right. Now I'm welding towards myself. I said, you know what? I think I'm okay. I'm going to weld towards my hole here. So you can weld in different positions. You don't always have to weld from left to right, right to left. You can TIG weld, and you should be able to TIG weld in many different positions as needed. So I'm welding towards myself so I have a really good view of the crack I'm welding. And there it is. So there you can see the first weld right there. And I can already see, if you look in the middle, you can actually see a small crack developing. You see that? See it? Yeah, very, very interesting. So remember, we have no idea what this is. This is a cast metal of unknown origin. I don't know what it is. I'm using my best guess to repair it. I'm using my best, experience to kind of figure this thing out. It doesn't always mean it's going to work, So I'm going to layer some more beads in there, and it should work. Hopefully it'll work out okay. But we'll see what happens. That's one of the difficult things. If you don't know what the alloy is, it gets very tricky to match the filler metal to the weld you're doing. It can be very problematic. So, yes?
Is there a certain pass you should be using the rod with the torch?
What do you mean by certain pass?
You using the rod with every pass?
Yes. Because I'm filling the gap. Yeah.
Oh, okay.
So in this case, I'm filling basically drop by drop. I'm filling every time I'm going in because I want to fill up this gap over here. Yeah, kind of my root pass. Yeah. Intermediates and then cover. So let's see what happens here. So I'm gonna add some more metal in there.
So you're using 2 or 3 different.
And the whole time you're doing it, you're just making a little spin, right? You're spinning it around.
Kind of, not really. So that's a different thing here. When I press down on the pedal, increment amperage spreads out my weld pool.
Okay.
I feed and add amperage, that spreads my pool. As I back off, it shrinks that pool. Now, there are, if you have a long leg on your weld, yeah, you might manipulate your rod a little bit. More often you're manipulating your torch. Your rod kind of stays there, but you move you have to, you move your torch to move the metal where you want it to go.
Yeah, that's what I'm doing.
Yeah, but because I'm going down right into a hole, I'm moving a very slight bit, but not very much. But really it's your rod feeds this way, your torch is doing any manipulation.
Okay.
We want to coordinate these two movements together.
So circles?
Kind of like just side to side, or kind of a C shape. Again, this is one of those things that as you do it, you're going to kind of find what pattern works for you. All right, so let's do another one. Let's get back over here and fill that side a little more. So I'm going to get my pool going, heat it up a little bit. You can see the shimmer, everybody see that? So I'm going to backfill over here because I can weld backwards if I need to. So backfill like this. Okay, I may have to turn this around and do that side, I think. If I do that. Okay, slip that there, would you? The block, put the block there. Right here, this one. Just grab this one, just grab it. It's not hot.
Okay. So
Go. Thank you. This is hot, not that. Okay. There we go. Alright, so I'm gonna do this side right here, throw this in. Cover. Oh, you hear that? Yeah.
Is it keeping it?
Okay, so let's run another pass on top of this thing. So I'm going to run this way this time. Alright, here we go. Another pass. Get my tool going. Okay, I'm moving my torch side to side very slightly just so I can fill my gap. See that? You can hear those clicks and pops once in a while. Those are trapped gases burning out of the cast material. Cast aluminum is really bad for that. That's one of the worst. So cast engine blocks, cases, very difficult to weld. You can see my tungsten is about a 1/4 inch away or so. We are.
I couldn't really see it because it was darkened the whole time. But
Yeah, so now if we look at this, notice, see that my heat affected zone is pretty regular. You see that? So that means is I'm applying the same amount of heat from here to here. It's very constant. So you know, there's a little discrepancy here, but it's pretty much parallel. It's not too off. So when you're welding, if your heat affected zone is like blah, 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 like that means that your application of amperage is really irregular. So you can look at your own work. If your heat affected zone is dead parallel to your weld, like, all right, my time and temperature is really exacting.
I think you
This
guys
is
give
good.
the thicknesses of steel here between this and the back is thicker, but this is constant on
Ah,
this side.
you're right, exactly. Yeah, so that's the discrepancy. You're right. That's what's different. In fact, that's why I think it cracked actually. Think about how it cracked. You've got a thick, hard blade here, then this really thin piece right here. The thing what happened is it probably hardened when this thing was made and cooled. There's probably a crack here when it was made.
Yeah.
I think the metal cooled irregularly. This cooled much faster than this, and it shrank away and cracked. Yeah.
Yeah, I think what you just said really applies because there's still like a little gap right there on this
Yeah,
side
I'm gonna
there.
fill that. So I'm gonna do one more pass on top of here, hit the ends, and
When you flip it over, you see like this little tiny
It
hole.
must have been otherwise.
yeah.
You see that little tiny hole?
All right, so let's weld that up. Let's see. All right. So again, changing the angle. I can't reach it, so I need to change my angle. So figure it out. Change your angle, change your setup so that you can get into what you got to work on.
So the most important thing to remember is weld to be comfortable.
Yes, always. You can't weld if you're not comfortable. And if somebody tries to force you to weld when you're not comfortable,
Tell them no.
yeah, walk out. Seriously. I mean, I had a student I talked to a few days ago, and he was telling Carol and I about a shop that he went to for a job, and he said the place was like, you know, he was like, no, I'm not working here. So the place was just not set up for the comfort and well-being of the people working there. Doesn't matter how much money it is. It's not worth it. You'll get hurt there. All right, so let's weld this up. You're right. So get the crack. I got to adjust my position. Let's get in there. You can see those little, if you see any sparks coming off the surface, you see that? All those sparks are impurities. TIG welding does not produce sparks. Any sparks are in the material. So right now I'm doing drop by drop. I'm adding metal as needed. You see that? I can come in and kind of just drop in metal where I need to drop in metal. Great advantage when you're welding precision work. And also, see the color? See where it turns green once in a while? So, again, when you see your plasma, like, suddenly turn green or something, or orange, those are signs of impurities, either dirt in the surface or in the metal itself. Your plasma stream should be a pretty bright, like white, little blue. Any other colors showing up, it lets you know there's some dirt in there, whether it's your metal's dirty, your wire's dirty, maybe your gas is, you might have a leak in your gas line. We've seen that once. We've seen it in the shop where like a hot spark hits it, we got a pinhole in the gas line. We tear the whole machine apart and later on discover by putting it into a bucket of water, that's where it came from. So any discoloration to that plasma, investigate where it's coming from. You got something you got to deal with before you can move on. So this metal is really dirty. All right, so that's closed. So now let's see about closing it up. So I'm gonna
You can
get.
tap that, you can do.
Yeah. Yeah.
There's
I
no
don't
cracks
actually.
forming? I can't see my, you can do that.
It looks, no, that actually came out pretty good. So that's sealed. That's sealed.
good weld.
Now the reason it's sealed is this. Very important concept here in welding. I don't know if we've talked, did we talk about dilution? Very important concept, not just with TIG welding, but actually all welding in general. So, I like soft serve ice cream. I like those half chocolate, half vanilla cones, the swirly cones. What happens to a swirly cone in the summertime? Yes, and you got chocolate and vanilla. After a little while, what do you got in the cone? It's like light brown. It's not vanilla, it's not chocolate, it's something else. Now, dilution is one of the things in welding that we really want to be aware of. Now, when I welded that first pass in there, okay, I'm melting what they call the parent metal with my filler metal. So they're going to be mixed together, and they're going to melt together, forming something new. When I put my next pass on top of that, it's going to melt less into the parent metal. Okay, when I do my third pass, I'll have more of this. Each subsequent pass is more and more of this metal, less of the parent metal. Okay? So these alloys are actually specially formulated to compensate for dilution. So it's like, oh, can I use any weld rod? No. There are a lot of welders who think you can grab any old weld rod and throw it into there and use it. No, 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 no. They're specially designed for certain things. Dilution is a big enemy. As you fill in your metal, it's going to weld into this and form a new type of metal. It usually works, but dilution is an important thing to keep in mind, because if, like, say you're welding and you're really, really, really hot, you're going to melt way more of your parent metal into the mix. You're going to have less of your filler metal. And when you're done, it's almost like diluting the glue with water. It's not, your strength is not going to be there. So this is an important concept to think about. Dilution is a fact of life for what we do. So by welding multi-pass, I can add more of the metal I want and kind of control that dilution by passes. We'll talk more about this when we do next class together, 157, when we do the groove welding. We'll talk a lot about dilution, interpass temperature, and about what that means. That'll be big for us when we do the weld testing. But for TIG welding, important thing to keep in mind. So here, the first pass you saw it cracking because it was mostly this metal. Now, third pass, it's mostly this, the crack is gone. So now I'm gonna put another pass on top, and with luck, it'll come out nice and clean. Now to make this even better, could you grab me a brush in there if there's one there?
How does this color look to you?
The color is not bad considering how thick this is. I think it's okay. I mean, if this were really thin material, it would be kind of like, uh-oh. But being as it's so
That
thin,
first crack show up? Or is it
um,
gone now?
it's probably gone by now.
You've kind of fused back into
Yeah,
it?
so if we look at the weld, you see how, so if you look at the weld, you see how it's uniform in depth. My ripples are very uniform and very regular. This is what we're aiming for, okay? Uniform depth, I'm filling it with the same amount of metal each time. Think about having a nice big, a nice big tray full of those little paper cupcake tins. And you're pouring the batter equally into every single tin. I'm pouring metal equally into every single drop I'm putting down. Same metal, same temperature, means the same strength throughout the entire weld. Predictability. So somebody says, how strong is that weld? I can say, I know exactly how strong it is. I can predict it, I can tell you how strong it is.
For this particular weld you're doing
Yeah.
here, you're purposely building up, doing multiple passes.
Yes.
If you try to do it all at once, maybe you could, but it's not necessarily going to be a good weld.
It'll,
It won't be as strong.
you know what? We will try that at some, all right, folks, when we do the groove welds, let's try that for the hell of it. Try and see if you can do the groove weld in a single pass. Now, it is possible. Is it recommended? No, because it'll be crazy. So we can try that, but it's going to be very difficult. So I'll do the final pass and let's get this thing filled up. This should
Are
be
you going
enough.
to fill in the other crack too?
Oh, I want to sharpen my tungsten. Let me go hit that really quick.
Wow, it really is gold.
Yeah, so you see what happened there?
Yeah.
So that is solely from the heat. The heat erodes it away. I didn't touch the metal. It just gets eroded away by the heat. Even though it's tungsten, it's supposed to, it lets you know just how much power is going on there. Remember, this is 10,000 degrees, people. A lot of power. So I'm going to quickly touch this up and get my point back.
What?
No, that's for me.
Yeah, that's like one of the cubicle, and they have like a little dial.
So I think for fun, I think at the fun, when I'm done with this, we'll, anybody wants to take a turn on here and we'll watch, you're welcome to. How's that sound?
Take a turn.
Yeah. Take a turn on doing some TIG welding. Nah, because that's client material, so no. But if you'd like to,
I mean, yeah, don't worry. It'll last another 2 years. Just, another 2 years, bring it back.
thank you. But if you'd like to try it out, we can kind of open it up and you can drive the chair and we'll see what happens. It's a lot of fun.
I would take it a minute.
So,
Here we go.
next
Yeah.
up is
I said I was taking a minute, but
What kind of stuff do you want to take as opposed to other things?
Well, it's more controllable because it's just I want to do this in a manner that's really controllable. I imagine if we were stick welding this thing. I mean, you might look at your visibility. You know, you can't see anything at the smoke. Your slag's over here. Here, I can see right into the crack. I can watch exactly what I'm doing the whole time. So yeah, there's a big advantage to that, to having that level of like I can actually see what I'm doing, which is really nice. All right, let's get back in there. Cover up. Oops, sorry. All right, here we go. You see after sharpening see how much brighter my weld pool is? You see that? That's the benefit of keeping your weld pool nice and your tungsten nice and sharp. So I'm just kind of alternating from side to side here.
you doing a little bleed?
Yeah, let's get it's a wide pool. Look.
Hasn't got too hot.
So there you can see I'm filled right to the surface right there.
Yeah, it looks real nice. Real pretty.
All right, so let's get back in, so cover. Yeah, it's going very gray because, yeah, this is a really thick piece of material. Like you said, 1/4 inch, you're running kind of the functional limit for TIG welding, but I like the precision and kind of the surgical nature of the precision here. It's really valuable. So there it is, right there. And I'll add a little more over here just to fill that up.
Fill that corner.
Yeah, just fill that corner up over there. Right.
What do you do with this? So like, this is really deep. How are you gonna get in there?
I will do my best. I'll probably use
real
a tiny
deep, but
little
it's
wire.
real narrow.
I'll probably do my best, you know? So let's see. All right, so here, and like that, right there. Now I'm just adding metal as needed. You see that? I'm just adding where I need to build up that edge. There you go. So I can just add where I need it and move it around and just fill where I need. So that looks pretty good.
Question.
Yeah,
That looks great.
So,
yeah.
I'm trying to figure out how to phrase this. I mean, like,
Yeah.
phrase my question.
All right.
So with the TIG welder, I mean, you're essentially hovering. You don't want the tungsten to...
No, the tungsten shouldn't touch the surface. No, it hovers over the surface. So your tungsten hovers over the surface about 1/4 inch away or so. Sometimes a little closer. I mean, because it's a groove, I was kind of down in there. So 1/4 inch with 1/8 inch in height, you're kind of hovering over there.
So then with the metal, you just like add as it's needed.
Add as needed. You don't always need that metal, but sometimes we do. We
So,
just as needed,
Due to
yeah.
how hot it is, you could just like add essentially small portions of the metal after you leave the...
Yeah, if you
area
want to,
where-
sure. So that is, I'll do the rest later with my evening class. But just because you heard earlier, could you, on the end button, see the end button there, which is polarity, can you press that?
This one?
Yes. Now it's set to AC. So just so you see the difference. So that was DC. How quiet that was? Very quiet. Yeah.
I like the rhythm to it.
Yeah, the rhythm. So this is quite hot. So be careful with that. It's very hot. Be careful. That's quite smoky and scary. We do have lots of. I save all the dull saw blades. These are fantastic for practicing on. So I save these, and we do butt welds and fillet welds with these. So if you can do this, you're good. Seriously, for aerospace, this is what you need to do for aerospace. We're going to practice this year. Yeah, fillet welds, lap joints, and butt welds are material this thin, right here. We have lots of this because the saw blades, they break them all the time. Yeah.
That's a high carbon blade, right?
It is, yes. But it's still weldable. It's a little tricky, but it's still weldable. It's good practice. Okay, so alternating current is used for aluminum because of this. Aluminum has much higher thermal conductivity. So all metals conduct heat at a certain rate, okay? So steel, if we call steel 1, okay? Steel is our 1 because we know it. Aluminum conducts heat like twice as fast. Stainless steel, if steel is a 1, stainless steel is 0.50. It conducts heat only half as good as steel does. So one of the challenges, say, of stainless steel is it takes a long time to heat up and a long time to slow down, which means when you're welding on it, there's a serious lag. But then you're like, oh, it's not hot enough, and you floor it, and then before you know it, it's like it runs away from you. So that's a challenge. That's why stainless steel said, why is stainless and anything else so hard to weld? Because there's like a lag. It takes it's very sluggish. It doesn't want to heat up and it doesn't want to cool down fast. So it's really easy to overheat it before you know it. Aluminum, on the other hand, it conducts heat so ferociously. That's why it's used for cooking pots. You know, aluminum outside on a hot day is like murder, you know? So the trouble here is this. If I try welding aluminum on DC, it sucks away the heat faster than I can pump it in. So what happens is I can't get a weld pool going. Now remember, DC is only the top half of the wave, okay? It's just this part. AC, I'm using both halves of the wave. So with AC welding, what happens is your waveform is going to be like this, okay? It's called, you're going to have what's called your cleaning action and your heating action, okay? The waveform moving into the metal is our heating wave. That wave is heating the metal. Then the wave moving this way, out of the metal, is doing something called cleaning, which is, even though I clean the metal, I'm going to clean this off, it's going to blast off the surface oxides and contaminants. And you're going to see that. It's going to leave like a white, frosty surface.
The flow of electrons is different. Also.
Yeah, it blasts them off the surface. So one wave is blasting material this way, the other wave is blasting this way. So,
Chapter 9 goes into that.
yes, chapter 9 goes all into that. So let me quickly rub this off. Acetone. Huh?
It was something about chapter 9. It was really in the
Denatured alcohol,
beginning.
that's what I was thinking of.
There you go. Ta-da, so you can see all the crud coming off it right there.
Is denatured alcohol something? That's heating, that's the
The fuel alcohol?
solid.
Yeah, that will work. Now,
Yeah.
yes, it will work. It's a good question. Now, the fuel alcohol will work. Like 100%, as close as you can, will work. When I did food processing stuff, we couldn't use acetone. When we did food processing or pharmaceutical equipment, everything we used had to be food grade. So we had to use like food grade oils, food grade lubricants, anti-seize.
Yeah.
The anti-seize was basically like Crisco. I mean, you could eat it if you had to. Because everything we were doing was used for food, like making peanut butter or jelly or something. So all the chemicals we used had to be like, they had to
You were
be.
saying fuel, bro. You was really saying food. Oh, okay. All right.
So we couldn't use acetone. We couldn't use that because of contamination.
He has
You
an
know?
accent like
So I am from.
Now that's what I was saying when I heard you saying food. Like,
Well, no, we do. No, we do have you. There are a whole class of food grade chemicals you can't, that sometimes you have to use for certain things. This isn't, so we couldn't use that. We used alcohol, and it worked. It works okay. If it's a high, like 100% alcohol, you're good. But be advised, your like ordinary household grade rubbing alcohol is 30% water, and that water will leave residue on the surface, causing problems. So if you can get like at the hardware store fuel alcohol.
And denatured alcohol is probably correct.
Yeah, you want to get fuel
Playing with it,
alcohol.
I don't know what I do. I wouldn't use it.
Test it out, you know, test it. If you start seeing sparks or weird colors,
Yeah, oh, okay.
the fuel alcohol, it's like the green one with the green label, like at Home Depot, fuel alcohol for alcohol lamps. That one, yeah, that one you can use. Yeah, that one will work. Yeah, that one's fine.
They've kind of crossed brands now. I used to
Yeah.
buy denatured alcohol, now they call it fuel.
I know. Same stuff.
One's craft, one's craft.
All right, so here we go. So now I've got,
Now, quick question.
yeah,
You're going to do aluminum,
Yes.
right? So you change it to AC.
Yes.
What about the gas?
gas. Oh, good call. So argon is universal TIG welding gas. You can use argon for any TIG welding process. If you use another gas, it's only to get like a certain like advantage. But argon is like, you can TIG weld anything with argon. Now, yeah, I've used helium. Helium they used to use because a long time ago helium was abundant, but it's still expensive. I mean, that was used by the military. Helium is very expensive. Also, helium is very